Okay, hello, finite math students. This is your teacher, Mr. Lewitt. Um, let's go over problem number 82 in your linear programming and simplex algorithm homework. So this particular problem, well, obviously it's a word problem or an application problem. I prefer to call it an application problem because there are words in every problem. So this is really an application problem. Um, so this problem is going to use duality. All right, this is a typical minimization problem where all of the constraints are going to be greater than or equal to. And in order to solve this problem, we are going to use the concept of duality that was explained and demonstrated in my previous video. Okay, so let's go through the problem. This may take some time, but that's okay. So I hope everyone is doing the homework, and I hope that you're being honest about it. I don't mind if you get outside help. I mean, that's okay, that's fair. What I object to is when you tell someone, here, I'm just going to pay you, a few $100s, and then you just do the entire homework assignment for me. That's extremely dishonest. And not only that, but in the long run, you are shortchanging yourself because you're not learning anything by doing that. I mean, it's okay to pay a tutor. It's okay to pay a tutor to help you learn the material, but it's not okay to pay someone to just do the homework for you and not explain any of the homework to you. So, if you pay a tutor, I think that's okay as long as the tutor is working with you and helping you to learn the material. But you should never just pay someone to do the homework for you because then, you're not learning anything. So yeah, I just want to make that very clear, okay? Okay, so let's go through the problem. Let me make sure everything is set up here. I have Mathematica. Um, let's see, I have my drawing tool. Okay, that looks good. Okay, so the problem reads, a dietitian in a hospital is to arrange a special diet using 3 foods labeled L, M, and N. Each ounce of food L contains 10 units of calcium, 5 units of iron, 40 units of vitamin A, and 20 units of cholesterol. Each ounce of food M contains 5 units of calcium, 5 units of iron, 60 units of vitamin A, and 20 units of cholesterol. Each ounce of food N contains 5 units of calcium, 5 units of iron, 40 units of vitamin A, and 18 units of cholesterol. Select the correct choice below and fill in any answer boxes present in your choice. If the minimum daily requirements are 150 units of calcium, 100 units of iron, and 960 units of vitamin A, how many ounces of each food should be used to meet the minimum requirements and at the same time minimize the cholesterol intake? So that's a little confusing when it says just minimize the cholesterol intake. So if we're going to minimize the cholesterol intake, that means, well, we're going to have a cholesterol. Let me see here, one moment. Select the correct choice below and fill in any answer boxes present in your choice. If the minimum daily requirements are 150 units of calcium, 100 units of iron, and 960 units of vitamin A, how many ounces, excuse me, how many ounces of each food should be used to meet the minimum requirements and at the same time minimize the cholesterol intake, which means that the cholesterol constraint is going to have to be greater than or equal to 0. Greater than or equal to 0. Okay, so hold on just one moment. I'm just taking a sip of tea to relax my throat and voice. So I have to figure out. Okay, so they're using X1 ounces of food L, X2 ounces of food M, and X3 is equal to, okay, ounces of food N. There is no way to minimize the cholesterol intake. Okay, so the constraints are pretty easy to figure out. It's the objective function that's going to be a little bit tricky. Maybe not necessarily. Let me write this down for you guys. This problem is a little bit tricky, but let's see if we can figure it out. So let's talk about the calcium. Let me try to write this out. The calcium. Okay, I know it doesn't look pretty, but I'm trying to write with my trackpad, my laptop trackpad. It's a little tricky. My calcium constraint. Okay, this is a little bit tricky. So if we're looking at just the calcium constraint, each ounce of food L contains 10 units of calcium. And let me see, each ounce of food M contains Each ounce of food M contains 5 units of calcium. And let me see. Each ounce of food N contains 5 units of calcium. And we have this restriction. There is a minimum daily requirement of 150 units of calcium. So that's going to be 150 on the right side. So let me make sure this restriction makes sense. I'm going to read the problem more carefully. So each ounce of food L contains 10 units of calcium. Each ounce of food M contains 5 units of calcium, and similarly, each ounce of food N contains 5 units of calcium. The minimum daily requirement for calcium is 150 units. So this is the calcium constraint, and it does make sense. So next, okay, this is where I wish I had a whiteboard or a blackboard or something bigger to write on. Next, we have to worry about the iron constraint. I'm just going to, instead of writing the whole thing out like I did with calcium above, I'm just going to write Fe. That's the chemical symbol for iron. The Fe constraints. Okay. Fe constraint. Okay. Fe is the chemical symbol for iron. Okay. I think Ca is the chemical symbol for calcium. Okay, so let's look at the iron constraints. Let me see. Each ounce of food L contains 5 units of iron, 5 units of iron. So each, let me read that again carefully. Each ounce of food L, each ounce of food L contains 5 units of iron. Each ounce of food M contains 5 units of iron. Okay. And each ounce of food N also contains 5 units of iron. Okay, and that's going to be greater than or equal to, let me see, the minimum daily requirements are 150 units of calcium. Okay, and here we go. 100 units of iron. 100 units of iron. Okay, guys, this is getting very messy, so I'm going to write this down on a piece of paper. I'm going to pause the video to just copy this down because I have to erase it. Otherwise, I can't really see my screen very well. So let me just pause the video for one moment. Pause. Okay, so guys, please write down your calcium constraint and your iron constraint because I need to clear my screen so that I can continue because my screen is getting cluttered, very fast, and I need to erase this in order to move on. So your calcium constraint is 10L plus 5M plus 5N is greater than or equal to 150. And remember that L, M, and N represent your 3 types of food. Your iron constraint is 5L plus 5M plus 5N is greater than or equal to 100. Let me erase this so that we can continue. Okay. Next, we need the vitamin A constraint. Okay, so we have our vitamin, let me see, the vitamin A constraint, the vitamin A, this is really hard to, okay, there we go. Yeah, I'm using this app that enables me to draw with my trackpad, but it's a little tricky. Okay, so I need to work on my vitamin A constraint. So let me see. Each ounce of food L contains 40 units of vitamin A. 40 units of vitamin A. And each ounce of food M contains 60 units of vitamin A. And each ounce of food N contains 40 units of vitamin A. Okay. Let's see. The minimum daily requirement of vitamin A is 960. 960. Okay, so I'm also going to write that down. So we have 40L plus 60M plus 40N is greater than or equal to 960. Okay, terrific. And of course, we can't forget, okay, there we go. L, M, and N all have to be greater than or equal to 0. Okay? So now we have to figure out the objective function. What are we actually minimizing? We're minimizing cholesterol. We're minimizing the amount of the total amount of cholesterol in, these servings of food. So I'm going to say cholesterol is just C for cholesterol, or if you prefer, CH. Okay, so cholesterol is going to be equal to, let me see. So food L contains 20 units of cholesterol. So food L contains 20 units of cholesterol. Food M contains 20 units of cholesterol. Okay. And let me see, food N contains 18 units of cholesterol. 18 units of cholesterol. So this is the objective function that we're supposed to minimize. We're supposed to minimize the total amount of cholesterol, but we have these restrictions where we need at least 150 units of calcium. Oh, 1 second. Yeah, we need at least, hold on 1 second. We need at least 150 units of calcium. Okay, I'm reading, there we go. I'm reading the bottom part of the problem. The minimum daily requirements are 150 units of calcium, 100 units of iron, and 960 units of vitamin A. So we need to maximize our calcium, our iron, and our vitamin A, but we need to do it, at the same time, we need to minimize our intake of our intake of cholesterol. So this is your standard minimization problem because all the restrictions are greater than or equal to. All of the restrictions are greater than or equal to. So this is important to keep in mind. Let me just change one thing over here. Okay. When you have a standard minimization problem, and that's exactly what this is, all of your restrictions are going to be, all of your constraints or restrictions are going to make use of, all of your restrictions or constraints are going to make use of the greater than or equal sign. Okay, all of your constraints are going to be greater than or equal to constraints. In a standard or typical minimization problem in linear programming, all of the restrictions or all of the constraints are going to be greater than or equal to constraints, but you're still trying to minimize your objective function, and this right over here is your objective function. So let me write that down before I forget it. So my objective function is 20L plus 20M plus 18N. Okay, fantastic. And that's my, that's my objective function. Okay. All right, just wanted to write that down on a piece of paper because I need to, clear the screen. Okay? There we go. So why don't we get started? Let me just, hold on 1 second. Let me just put away some stuff on the desk very quickly. Okay. Okay. So what I'm going to do, now remember, I'm going to have to solve this problem using duality. I'm going to have to solve this problem using duality, which means I have to take the transpose of the matrix whose values are the coefficients of my constraints. But forget about the right-hand sides. We're going to forget about the right-hand sides for right now, okay? So that's a little bit confusing, but you should remember those values. So here, let me write this down. So if you remember correctly, so we had 10L plus 5M plus 5N, correct? And then, greater than or equal to 150. And then we had 5L plus 5M plus 5N is greater than or equal to 100. And then we had 40L plus 60M plus 40N is greater than or equal to 960. So those values, 150, 100, and 960, those become the coefficients of the new objective function that we're going to maximize. And then the cholesterol function, which is equal to 20L plus 20M plus, the cholesterol function, which is equal to 20L plus 20M plus 18N, those coefficients, 20 and 20 and 18, are going to become the resource values in my new constraints of the new maximization problem. Okay, so this is what I'm talking about. So we have a matrix A, 10, 5, 5, 5, 5, 5, 40, 60, 40. Okay, but it's important to take the transpose of that matrix. You have to take the transpose of that matrix. So A is equal to transpose A. Oops, nice. Okay. So let me erase this, guy, so I have a little bit more room on my screen. This is a small laptop. I'm using a laptop that is a lot smaller than the laptop I used for my previous video. All right, I'm using a laptop that's a lot smaller than the laptop I used for my previous video. So I need to budget my space carefully. So let me just erase the stuff I wrote. Okay. So next, I need to augment matrix A with a 3 by 3 identity matrix. Okay. Hold on one second. Okay, so A is equal to join A identity matrix. Identity matrix 3, and don't forget the number 2 because I'm dealing with matrices rather than linear lists. Matrix form. Okay. So then I'm going to augment that with the coefficients on the right-hand side of my cholesterol function. Okay, this matrix that I have so far needs to be augmented with a column vector or a matrix of the coefficients coming from the values, the terms of the right-hand side of the cholesterol function. Okay, so that's going to be A is equal to join A 20, 20, 18. Don't forget the 2 because I'm dealing with matrices. I'm joining matrices, not linear lists. Okay, but now don't forget, I need to worry about that bottom row. I need to worry about that bottom row. So, oh, and actually, you know what? I probably should have taken care of that in the beginning. So you know what? Hold on. Let me start this over because, yeah, let me start this over, guys. Hold on one second. So, um, well, no, that's okay. Hold on one second. This is going to get a little confusing. Let me clear A. Let's just start over. Okay, clear A. So A is equal to 10, 5, 5, 5, 5, 5, 40, 60, 40, matrix form. Matrix form. Okay. But the problem is here. Okay, I need to insert. I need to insert those right hand values 150, 100, 906. Actually, hold on just one second. So yes, let me do that right now. So hold on one second. Let me start this over. Hold on. One more time. Clear A. Okay, let's start this again. A is equal to 10, 5, 5, 5, 5, 5, 40, 60, 40. Okay, I need to insert this now, otherwise things get more complicated later on. So we're going to take those right-hand values, the resource values of the original minimization problem, 150, 100, and 960. We're going to negate those values, and those values are going to become the bottom row of this matrix. So it's going to be negative 150, negative 100, negative 960. Okay. This needs to get augmented by the 4x4 identity matrix because I see 4 rows. All right, so this is the first, this is the second, this is the third, that's the fourth. So I have 4 rows, okay? So I need to augment this matrix with the 4x4 identity matrix, and then we need to augment that again with the column vector or the matrix 20, 20, 18, and 0. Okay, let's try that. A is equal to join A identity matrix 3. I wonder if I could do it all at the same time. I'm not sure. Maybe. I'm not sure. So join A identity matrix 3. We can try it. I don't know if this is going to work, but we can try it. 20, 20, 18, 0. Oh, this should be identity matrix 4. Sorry. Actually, it does work. So let's make the change permanent. We're going to update A. Okay, now we can go ahead and solve this just like a regular standard maximization problem in linear programming. Okay? So let's go ahead and do it. The column that has the most negative value in the bottom row is which column? It's going to be the third column. This is the column that has the most negative value in the bottom row. Okay? So let's see, 20 divided by 5 is 4. 20 divided by 5 is 4. 18 divided by 40 is obviously, it's going to be less than 1. It's actually going to be less than a half. So then this is where we're going to have to pivot right over here, right? Because I know that 18 divided by 40, it's even smaller than 1, right? Which is smaller than 4, okay? Which means I have to pivot right here on the 40, okay? So let's start. So we're changing the third row. And how are we changing it? We're multiplying the entire third row by the reciprocal of 40, right? So there we have it. Okay. How are we changing the first row? It's the first row. The new first row is equal to the old first row minus 5 times the third row. And then the second row, we're going to change it in the same fashion as the first row. Okay. And then finally, we have to manipulate the fourth row. So the fourth row is equal to the fourth row plus 960 times the third row. Okay, so now let's take a look at the bottom row. Let's take a look at the bottom row. Don't worry about the last two values, not yet. Look at these values right over here. Look at all the values of the bottom row except the last two values. Are any of them negative? The answer is no. Are any of them negative? The answer is no. Everything here is either 0 or positive, which means we're done. We have the answer. We have the answer that we want. Okay, we have the answer that we want. Okay. Hold on, let me just pause the video for one moment. Okay. Let me just pause the video for one moment. Okay, so now we need to find our answers. We need to find the answers to the original problem. Let's see. So, let's see now. Hold on just 1 second. Okay, so, excuse me. The answer is going to be found in the bottom row. The answer is going to be found in the bottom row. So x1, x2, and x3 are actually represented by these columns right over here. Okay, this is going to be, excuse me, this is going to be x1, x2, x3. And we have to look in the last row of those columns. So the value for x1 is going to be 0. The value for x2 is going to be 0. The value for x3, the value for x3 is going to be 24. Okay, and the minimum value of the objective function, the minimum amount of cholesterol is going to be 432. The minimum value or the minimum amount of cholesterol is going to be 432. Now let's see if this actually makes sense. Okay, let's go back to the original problem. Okay? So we have x1 is, excuse me, x1 is equal to 0. We have x2 is equal to 0. We have x3 is equal to 24. Okay, let's look at the restrictions. Is x1 greater than or equal to 0? It's true. Is x2 greater than or equal to 0? That's true. Is x3 greater than or equal to 0? Oops, that should be 0. That's true. So that's easy. That's easy to see. Look at the calcium restriction. 10. Look at the calcium restriction. 10 times x1 plus 5 times x2 plus 5 times x3 is a greater than or equal to 150. Okay, so that is a problem because our first restriction is violated. So 5 times x1 plus 5 times x2 plus 5 times x3 is a greater than or equal to 100. Well, that's true. 40 times x1 plus 60 times x2 plus 40 times x3, it's greater than or equal to 960. So the problem really, there's a problem with the first restriction. So this is the issue, because that's supposed to be 150, and we're getting 120, which means we did not find the right answer, which means we need to go back and figure out what the mistake was. That's definitely not the right answer. So we need to go back and figure out the mistake. So that's really kind of weird. That is definitely a little bit weird. Let me go back, unless, whoa. Again, why do I keep doing this? Okay, I did the same thing in the last video where I forgot to take the transpose, and I did the same thing again here. Okay, let's go back. So this is not, it's close to the right answer, but it's not the right answer. So clear A, we have to start this again because I forgot to take the transpose. Okay, we're gonna get this right. So matrix A is equal to 10, 5, 5, 5, 5, 5, 40, 60, 40, 40, 60, 40. Okay, so I really need to remember to take the transpose. Okay, so A is equal to the transpose of A matrix form. Okay, that looks good. Now I need to insert the last row. So we're going to do, let me make sure I do this correctly. Hold on one moment. So it's going to be negative 150 negative 100, negative 960, position 4. Yeah, okay, that looks good. So let me make this change permanent. Okay. Yeah, so the problem is, guys, when I don't know why I forgot to do this. When I solved the problem, I did not use the transpose. So that wasn't too smart. All right, I don't know why I keep forgetting to do that. All right, we're going to augment that with the 4x4 identity matrix. Identity matrix, the 4x4 identity matrix, and we also need to augment that with the new resource values of 20, 20, 18, and 0. Okay. Okay, this is better than before. So this time we should have the right answer. Okay, so where do we start pivoting? Okay, so 20 divided by 4. 20 divided by 4 is 0.5. 20 divided by 60 is 1/3, or 0.333. And then 18 divided by 40. Well, let's see. What is 18 divided by 40? 18 divided by 40 is 0.45. So the minimum ratio is going to be right over here, which means that we need to start pivoting right over there. Okay? So we're going to pivot right here on the 60. Okay? So we're manipulating the second row. We're manipulating the second row. And that's 1 over 60 times the second row. Okay. And then the first row is equal to the first row minus 40 times the second row. And then the third row is equal to the third row minus 40 times the second row. Okay. And then the last row is equal to the last row plus 960 times the second row. Okay, we still have negative numbers though. Let me see something. Yeah, we still have negative numbers though in the bottom row. So we need to get rid of that. So we're going to pivot in this column right over here. Okay, because that has the most negative number in the bottom row. Okay, so 20 over 3 divided by 20 over 3 is, of course, 1. Okay. And then 1 over 3 divided by 1 over 12 is 4. And then 14 over 3 divided by 5 over 3, that's 2.8. So we're going to have to pivot right over here. The first row, first column, okay? First row, first column. So the first row of the matrix, the new first row, is equal to 3 over 20 times the old first row. So the new first row is equal to 3 over 20 times the old first row. Okay. And the new second row is equal to the new second row minus 1 over 12 times the first row. The new second row is equal to the old second row minus 1 over 12 times the first row. The new third row is equal to the old third row minus 5 over 3 times the first row. And then the fourth row, the new fourth row is equal to the old fourth row plus 70 times the first row. Okay, but we still have a negative number in the bottom row. So hopefully this will be, we'll have to pivot on one more column and we should be done. So we see a negative 5/2 in the bottom row, which means we need to pivot in the second column. So 1 divided by 1 over 4 is just 4. 1/4 divided by 1/16, let me see, I think that's 4. That's also 4. And then 3 divided by 5 over 4, that's, let's see, 2.4. So the minimum value, the minimum ratio is actually going to be found right over here. Okay? So that's where we have to pivot. We have to pivot in the third row, second column. Okay, so the third row is equal to 4 over 5, or 4/5 times the third row. And then the first row is equal to, the new first row is equal to the old first row minus 1 over 4 times the third row. And let's see what that looks like. The second row is equal to, the new second row is equal to the old second row minus 1 over 16 times the third row. Okay, and then finally, oh, sorry, no, that's the fourth row. We're changing the fourth row. The new fourth row is equal to the old fourth row plus 5 divided by 2, or 5/2, times the third row. Okay, and we're done. So how do I know that we're done? Okay, ignore the last two numbers of the bottom row for right now. Do you see any negative numbers? Do you see any negative numbers in the bottom row? Everything in the bottom row, forget about the last two numbers, but every other number in the bottom row is either 0 or positive. I don't see any negative numbers in the bottom row. Forget about the last two numbers. Do you see any negative numbers over here? The answer is no. Everything is 0 or positive, which means that we don't have to repeat the algorithm, okay? So if we look at, okay, so our new x1 is equal to 10, as you can see right here. The answers are right over here in the bottom row. These are going to be the answers, okay? Because these are the slack variables that correspond to the original minimization problem. So this is the L column, this is the M column, and this is the N column. Okay, so x1 represents, ounces of food L, x2 represents ounces of food M, and x3 represents ounces of food N. Okay, so then x1 is 10, x2 is 8, x3 is 2. Okay, so let's make sure that this actually works, okay? Is x1 greater than or equal to 0? Well, of course. Is x2 greater than or equal to 0? Of course. Is x3 greater than or equal to 0? Of course. Okay, let's check the calcium restriction. 10 times x1 plus 5 times x2 plus 5 times x3. Yes, it's greater than or equal, oops. It's greater than or equal to 150, which is true. 5 times x1 plus 5 times x2 plus 5 times x3 is it greater than or equal to 100? That is also true. 40 times x1 plus 60 times x2 plus 40 times x3 is it greater than or equal to 960? That is also true. Okay, now let's look at the objective function. 20 times x1 plus 20 times x2 plus 18 times x3, is it really equal to 396? Well, we know the answer is yes. 396. Is it really equal to 396? Obviously, we see, I'm looking at this number right over here, which, is 396. So, obviously we know that the answer is true. So guess what? I just proved that this has to be the right answer to the problem. So the special diet should include, let's see, what is x1 again? Oops, hold on one second. x1 is 10 ounces of food L. x2 is 8 ounces of food M. x3 is 2 ounces of food M. The special diet should include 10 ounces of food L, 8 ounces of food M, 2 ounces of food N, and that is correct. Continue. And the minimum cholesterol intake has to be 396 units, which is correct. Okay, so the issue is this. So there are a couple of issues. Number one, you have to remember to take the transpose of your original matrix. I forgot to do that when I first attempted to solve the problem, and that's why my answer did not make sense. Okay, when you're doing duality, when you're using duality to solve minimization problems, guys, you have to remember to take the transpose of the matrix of the coefficient values of your constraints. So you have a matrix of coefficient values. So my matrix was what? It was 10L plus 5M, okay, plus, 5N, right? And then 5L plus, 5M plus 5N. And then it was 40L, hold on one second, 40L plus 60M plus 40N. Okay, that's fine, but you have to take the transpose of this matrix, which is something I forgot to do when I first attempted to solve the problem. So what is the transpose? So this is our matrix, right? It's going to be 10, 5, 5, and then you have 5, 5, 5, and then you have 40, right? And then 60, and then 40. So if you apply the transpose function in Mathematica, what you're going to get is very simple. The first row becomes the first column. So you're going to have 10, 5, 5, right? The first row becomes the first column. Then the second row becomes the second column. So you're going to have 5, 5, 5. Right, so the first row becomes the first column, the second row becomes the second column, and then guess what happens to the third row? It becomes the third column. So then you're going to have 40, okay, 60, and then you're going to have 40. So it's important when you're using duality to solve a minimization problem. When you're using duality to solve a minimization problem, you have to remember to apply the transpose function to the matrix of coefficients from your original constraints, because otherwise you will definitely not get the right answer. Okay, you will definitely not get the right answer. Okay? And in case you're wondering, why are these problems a big deal? They are a very big deal. They're used a lot in business, economics. I know that in economics, they're very, very important. Okay, these linear programming models, these maximization and minimization problems are used a lot in economics. So if that's going to be your specialty in college, if you're going to study a lot of economics, if you're going to specialize in economics, you really need to know a lot about linear programming and other optimization techniques, other optimization algorithms. Linear programming is a very important optimization algorithm, but it's not the only one that's out there. There are other optimization algorithms out there that are also extremely useful and extremely important. Okay? Okay, I'll get rid of that. Okay, guys, so yeah, that was a lot of work, but that's okay, you know. And a lot of these problems, you know, 83 is very, well, 83 is going to be a little bit different. I think 83 is the first problem in the last section of this chapter. Okay, but if you get into if you look at the other problems, like 81 is very similar to what we just did. 80 is very similar to what we just did. Okay, 79 is very similar to what we just did. Well, let's see. Actually, 78 is slightly different because 78 actually uses mixed constraints. Problem 78 uses mixed constraints because you can see here less than or equal to. So the first two constraints use, I am talking to my dog here. Okay, the first two constraints use less than or equal to. The last two constraints use greater than or equal to. So that's actually a mixed constraint problem, and we haven't talked about that yet. We should talk about that actually in our next video. So I think in our next video, guys, we're going to start with problem 78 because problem 78 uses a mixture of two different constraints. We see less than or equal to constraints, and we see greater than or equal to constraints. And that's unusual because so far we haven't seen that, right? So in the next video, we're going to look at problem number 78 in the current homework assignment, okay? Chach, where are you going? I'm talking to my dog. Okay, I gotta get going, guys. I have to take care of my dog. All right, guys, be well, study hard, and let me know if you're having problems, okay? That's it for now. Take care. Bye-bye.